Hi students, last class we discussed about electrochemistry part 4. Now in this chapter we are going to discuss the part 5 of electrochemistry, that is the next continuation topic of last class. So here in the last class we discussed about what is Nernst equation. So what is the use of Nernst equation, how we are calculating Nernst equation, for what purpose we are using that Nernst equation that we are in the last class. So in continuation of the topic we are going to discuss now. So in the last class, what is the Nernst equation? Nernst equation is a equation. Nernst is a scientist. He discovered one equation to find the electrode potential of a cell. To find the electrode potential of a cell or EMF of a cell. EMF of a cell or EMF of a cell for the Daniels or any other cells, like that we discussed in the last class. So after that we did a problem on that one also based on that Nernst equation. So in this class, so we are going to discuss the extension of the topics, extension of that Nernst equation topic. Those are, so if you take how Nernst equation can be calculated with the reaction coefficient. Suppose if any chemical reaction is given, to that chemical reaction, how can you calculate the Nernst equation, and how can you write the reaction coefficient for that chemical equation by using Nernst equation, and how can you write the equilibrium constant Kc for the Nernst equation, and how can you calculate the pH. How can you calculate the pH, and how can you calculate the Gibbs energy for the Nernst equation? So based on that we are doing right now. So look at here. When you look at here, so this is part 5 extension of the Nernst equation topic. So now last class we did a Nernst equation completely. So Nernst equation we are writing here. So E cell is equal to E naught cell. E cell is equal to E naught cell minus RT by NF minus RT by NF ln, that is Zn plus 2 concentration by Cu plus 2 concentration. This is for the Daniell cell. Nernst equation, right? So generally you can write as a Nernst equation. E cell is equal to E naught cell. Look at here. E naught cell minus RT by Daniell cell. See here. Daniell cell means here n becomes 2. RT by 2F ln. See here. Zn gives rise to Zn plus 2. That means that is product. So products concentration by reactant concentration. This is the reactant. That is the reactant. So here we can write as a products concentration by reactant concentration. This is the ln. Ln means nothing but ln is equal to 2.303 into log. 2.303 log. So here that is Nernst equation. So now here, so this is the Nernst equation for the reactants and products for the chemical reaction. For chemical reaction is given. If a chemical reaction is given, so here it will become as N, because here we are not taking any Zn and Cu plus 2. So for Daniell cell it will become as 2. For general reaction, when reactants comes to the products, so here number of moles is equal to number of electrons transferred is equal to, becomes as N. So now here, if you write a reaction like this, for a chemical reaction like this, A moles into capital A concentration product reactants react with the B moles of capital B reactants gives rise to C moles of capital C plus B moles of capital D concentration. If the reaction is happening like this, and number of electrons transferred, Ne, number of electrons transferred, this is Ne. Electrons, N is equal to number and E is equal to charge of electron. Charge of electron. So if the reaction is written like this, if the reaction is given like this, how can you write the Nernst equation for this reaction? See, you look at here simply E cell. E cell is equal to E naught cell, E naught cell, E naught cell. Same like this, E cell is equal to E naught cell minus RT by. So number of here n means what? Number of electrons transferred. Number of electrons transferred. How many electrons are there in the equation? N number of electrons. That means n electrons. N electrons. So n into F. F means Faraday. How do you know that? F Faraday into ln. See ln products concentration. What is the products here? Products concentration. So products means C concentration into D concentration. D concentration. So here number of moles of products are C power small c, D power small d divided by, and A concentration reactants, because reactants will be there. Reactants A into A number of A moles of reactants. So number of moles is A small a into B reactant concentration into power small b. So for this equation, if any equation is given like this, we can write in the next equation as like this: E cell is equal to E naught cell minus RT by F log ln. So C products concentration to their powers, or products concentration to their powers to reactant concentration to their powers. So if you take like this, the reaction is written like this. So E cell is equal to E naught cell minus RT by. So if you convert it into this one, see here. If you substitute all these factors here, we will get 0.059 by n. 0.059 by n. So I am taking the L into log of products concentration whole power c, and this is also D, also one of the products, whole power d by A whole power A and B whole power small b. So this is A and this is B. So now here, this is a reaction for the general equation. This is a next equation for the general equation like this one. So now here we are converting into this one to reaction coefficient. So how can you write the reaction coefficient? Here E naught cell is equal to E cell is equal to E naught cell minus 0.059 by n, log of, look at here, log of, say what is Q here? Q means reaction coefficient. What is reaction coefficient? How can you write for this reaction? Reaction coefficient Q is equal to products whole power raised to their powers, products concentration whole power raised to their powers by reactants concentration raised to their powers. That is equal to Q. That means nothing but Q is the ratio of products concentration to their powers to reactant concentration to their powers. So here, if you substitute this value here, log Q based 10. Because why it becomes based 10? Because we are connecting ln to log. So what is the factor here? We can use ln to log. ln x is equal to 2.303 log x. 2.303 log x. This is in this way we can convert ln x to log x. 2.303 log x. 2.303 log x. So this is the equation for this is the final equation for reaction coefficient with respect to the next equation. So that means simply we can write as for this equation, by using reaction coefficient we wrote the next equation. So here we can write as next equation for a reaction by using reaction coefficient. By using reaction coefficient. This is an for a reaction. Which reaction? For this reaction. For this reaction. By using which one? Reaction coefficient. Reaction coefficient. Reaction coefficient. Reaction coefficient. So this is the next equation for this general equation. This is the next equation for this reaction by using the reaction coefficient. This is very important for doing the problems and also for objective purpose. So this is about the next equation. And next we are going to calculate we are going to do the equilibrium constant. Equilibrium constant. So this is reaction coefficient. Here we can write as reaction coefficient in bracket we indicate as Q. In bracket we indicate as Q. So if you want to also take a screenshot for this one. Next one. Next equation by using equilibrium constant. By using equilibrium constant. By using equilibrium constant. The next equation by using equilibrium constant. By using equilibrium constant. So here we are writing the next equation by using equilibrium. So first if you take a Daniell cell, what are the reaction will happen? Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Zn plus 2 plus Cu. Zn plus 2 plus Cu. This is the Daniell cell. So for this Daniell cell we are going to write the general equation as E cell. The next equation as E cell is equal to E naught cell minus 2.303 minus 0.3. If you substitute all these values, you get 0.059 by 2 log of Zn plus 2 by Cu plus 2 concentration. Log of Zn plus 2 by Cu plus 2 concentration. So this is the equation for the next equation for the Daniell cell. Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. So how many electrons are transferred here? 2 electrons. That we substitute all these values and we convert Ln to log means this equation will come. Now here we are going to convert so we are going to take we are going to write the equilibrium constant for the next equation. That means here equilibrium constant. So if you want to write the equilibrium constant means equilibrium, that means the total equation, the total reaction should be at equilibrium. So look at here. If we are going to write the equilibrium constant, that means the total reaction should be at equilibrium. At total reaction is at equilibrium. Total reaction is at equilibrium. That means total reaction is at equilibrium means total reaction is at equilibrium. That means here Zn plus 2 concentration, Cu plus 2 concentration, Zn plus 2 concentration, Cu plus 2 concentration is equal to Zn plus 2 concentration is equal to Cu plus 2 concentration. That means here this concept is very important. The total reaction is at equilibrium. Then only we can calculate the equilibrium constant. So here if the reaction is at equilibrium, Zn plus 2 concentration is equal to Cu plus 2 concentration. That means here concentration of zinc ions is equal to concentration of copper ions. That means here, so there is no passage of voltage in this Daniell cell. If Zn plus 2 concentration is equal to Cu plus 2 concentration, then there is no passage of voltage. That means here we can take there is no passage of current, means totally E cell is equal to 0. There is no passage of voltage. That means E cell is equal to 0. E cell is equal to 0. So then so here we are calculating an equilibrium. So at equilibrium, the reaction is, okay, write the reaction. This E cell is equal to 0. This E cell is equal to 0. E cell is equal to 0. We substitute this value here. 0 is equal to, substituting this E cell is equal to 0 in 1. 0 is equal to E naught cell minus 0.059 by 2 log of products concentration by reactant concentration. So here at equilibrium, so E cell is equal to 0. At equilibrium there is no passage of voltage. Why? Because Zn plus 2 concentration is equal to Cu plus 2 concentration. So automatically there is no passage of voltage, means E cell becomes 0. So at equilibrium E cell becomes 0. If you substitute this 0 value in 1, 0 is equal to E naught cell minus 0.59 by 2 log of Zn plus 2 by Cu plus 2. So here see. So how can you write Kc for this reaction? Generally you can write if any reaction is having Kc is equal to products concentration. Look at here. Products concentration by reactant concentration. Products concentration by this reactant. Reactant concentration. This is the reactant concentration. So now here, so what are the products here? Products is equal to Zn plus 2. Zn plus 2. Products is equal to Zn plus 2. So repeat it. Products is equal to Zn plus 2 by reactant Cu plus 2. Reactants are Cu plus 2. So now instead of Zn plus 2 by Cu plus 2, if you substitute this in 1, so now here this one here, if you substitute this in 2, this is 2. So substitute this value into this value in equation 2. This is equation 2. So if instead of Zn plus 2 by Cu plus 2, if you substitute this value into 2, you will get that implies look at it. This implies 0 is equal to E naught cell minus 0.059 by 2. Look at here. 0.059 by 2. Look at here. 0 is equal to, just we are writing this equation here. 0 is equal to E naught cell minus 0.059 by 2. So log of Zn plus 2 by Cu plus 2. So simply I am taking the log of Kc. Is it correct or not? Log of Kc. Why Kc? Kc is equal to Zn plus 2 by Cu plus 2. So now here, if you take this value to this side, E naught cell minus 0.059 by 2 log Kc. So this minus and this minus will cancel. So here we can take as E naught cell is equal to 0.059 by 2 log Kc. So here finally we can calculate the Nernst equation by using equilibrium constant as E naught cell is equal to 0.059 by 2 log Kc. So this is the Nernst equation by using equilibrium constant. We can write here Nernst equation by using equilibrium constant. Equilibrium constant means this equilibrium constant can be calculated only at equilibrium. So Nernst equation by using equilibrium constant. So this is about Nernst equation by using equilibrium constant. This is the final equation. So if you for notes, take a screenshot. So next one. Next, Nernst equation. Next, relation between Nernst equation, and Gibbs energy. Nernst equation and Gibbs energy. Relation between Nernst equation and Gibbs energy. And relation between the Nernst equation and Gibbs energy. See here. So generally Gibbs energy is written as so we know Gibbs energy in P1 we studied in thermodynamics. P1 thermodynamics we studied Gibbs energy. Delta G is equal to minus NF E cell. Minus NF E cell. Minus NF E cell. So G is what here? Gibbs energy. Delta means a change in Gibbs energy. So N is number of electrons transferred and F is a Faraday. E cell means what? Electrode potential. E cell means electrode potential. This is it. So here we can write as G is Gibbs energy. Gibbs energy. And F is Faraday. F is Faraday's. This is measured in coulombs. And E cell is electrode potential. Electrode potential. So M is the number of electrons transferred. So here, by using this Gibbs energy, we are relating with the Nernst equation. How can you relate this Gibbs energy to Nernst equation? As see, look at here. In the last one we studied that. See here. So if you take this Gibbs energy equation like this. If you take this Gibbs energy equation like this, so it gives a free energy, that means standard Gibbs energy, delta G naught is equal to, just we are taking this Gibbs energy to standard form, so delta G naught is equal to minus NF E naught cell, just simply for this first reaction, we are just taking the standard terms. So in the first reaction, general terms are there, delta G and E cell. For the first reaction, we are taking the standard terms. Standard terms are delta G naught is equal to minus NF into E naught cell. E naught cell. So we know that in the previous one, E naught cell is equal to. So E naught cell is equal to 0.0059 by 2 log C. So this is the relation. Just previous one we studied that E naught cell is equal to 0.059 by 2 log. That means this is the Nernst equation for equilibrium constant. So here Nernst equation for equilibrium constant. Now here, so I am changing this to like in the presence of n fact. In fact, it's like this. E naught cell is equal to. See, look at here. E naught cell is equal to RG by NF. Simply I am changing this 0.059 by 2 into NF terms. So here 2 is that means 2F. You can write as NF, that is 2. You can write as NF. In the place of NF I am writing. I am not substituting the 2 here. So E naught cell is equal to RT by NF. So this log becomes ln Kc. Look at here. ln Kc. So this change into this one. This one change into this one. So if you substitute this value in This equation is 1. Substitute equation 1. This one in 1. See, by substituting equation 2 in 1, equation 2 in equation 1, by substituting equation 2 in 1. See, look at here, this is equation 2, by substituting this equation 2 in 1. So what will happen? Delta G naught is equal to minus n of E naught cell, minus n of E naught cell. Look at here. See, delta G naught is equal to minus n of E naught cell. So in the presence of E naught cell, we are substituting this value. So now what will become as delta G naught is equal to minus n of E naught cell. What is E naught cell value? This one, RT by NF into ln Kc. RT by NF into ln Kc. So this NF will cancel. Then standard Gibbs energy delta G naught is equal to standard Gibbs and delta G naught is equal to minus RT by ln Kc. RT into ln Kc. This is the equation we get. See, next equation for the Gibbs energy. So the relation between next equation and Gibbs energy is delta G naught is equal to minus RT ln Kc. So this is our equation we derived and we related with the Gibbs energy. Next equation related with the Gibbs energy. So this is also one thing important for doing problems. So for notes we take a screenshot of this one. Next one, next equation related to pH. Related to pH. Next equation relates with pH and next equation related to pH. So how can you calculate the next equation related to pH? pH is what? Negative logarithm of H plus ion concentration. pH is negative logarithm of H plus ion concentration. So now look at here. So I am taking H plus. So 2H plus. One reaction is there, H plus react to H2. That means here 2 moles and here 2 electrons. H plus gains 2 electrons and become as H2. So now for this one, how can you write in the next equation? H plus 2, look at here, H2 concentration is equal to E naught cell H plus 2 H2, E naught cell H plus 2 H2 minus RT by NF, look at here, minus RT by NF, ln pH2 by H plus concentration, ln pH2. So why pH2? Because here in the presence of H2, in the standard hydrogen electrode concentration, we are taking pressure. How much pressure we are inserting there, that we are taking there. So ln pH2. So here we can write pH2 ln pH2 by H plus ion concentration. So look at here, H plus ion concentration. How many moles are there? 2 moles. We can write as 2 moles. Now here, look at here. In this, see, this is for standard hydrogen electrode. We are taking the standard hydrogen electrode. This reaction will happen, and here we are inserting the pressure of pH2. Here, this pressure of pH2. So for SH, look at here. For SH in the previous class we studied SHE. So SH concentration is 1 molar, the solution concentration is 1 molar, and the pressure is 1 atmosphere. Pressure is 1 atmosphere. At that time EMF of SL becomes 0. EMF of SL becomes 0. So that means here see this can be written as directly. I am writing like this: E of SL, E of H plus by H2 is equal to E naught H plus by H2. Just I am substituting the factors, will get minus 0.059 by 2. How many electrons? 2 electrons. 5 by 2 log of pH2 by H plus concentration whole square. Now here look at it. For standard hydrogen electrode, for SHE, we know for standard hydrogen electrode, this is not She, this is standard hydrogen electrode. For SHE, what is the pressure we have taken? Pressure of H2 is equal to 1 atmosphere. Pressure of H2 is equal to 1 atmosphere, and the concentration is equal to, and the concentration of the HCl is 1 molar, and here E naught of H plus by H2 is equal to what? 0. E naught of, see, electrode potential, standard electrode potential of She is 0, and here we are exerting a pressure of 1 atmosphere, and its standard hydrogen electrode potential is 0. So if you substitute these two values in 1, this is 1. So substitute these two values in 1. So what we get here? These two values in 1. So look at here. EH plus by EH2. That is E H plus by H2 is equal to H2 is equal to H plus H2 is equal to, look at it, E naught H plus by H2. So E naught H plus by H2 becomes 0. This is 0 minus 0.059 by 2 log of pH2 becomes 1. So 1 by H plus concentration whole square, 1 by H plus concentration whole square. 0 minus 0.059 by 2 log of 1 by H plus concentration whole square. Now here, look at here. So EH plus by H2 is equal to minus 0.059 by 2 log of, look at here, log of, so I am taking this denominator factor to numerator, it becomes as log of H plus concentration whole power minus 2. So here base 10 is there, here also base 10 is there, because we are converting into, here also base 10 is there, because we are converting to ln to log. So now it becomes as E of H plus by H2 is equal to, so if you take this one to here, minus 0.059 by 2 into minus 2 log of H plus concentration base 10. So how it becomes minus 2? See, look at here. Log A power x base C is equal to log A power x is equal to x into log E. By using this formula, you can write that one. So now here, this 2 will cancel, and minus plus. So E H plus concentration by H2 is equal to this minus plus. So 0.059 log of H plus concentration base 10. So here this is the EMF of a cell. So how can you write the H plus concentration pH? H plus concentration is equal to 10 power minus pH. Negative logarithm of H plus and concentration. So here we know this is already we know this one. H plus concentration is equal to 10 power minus pH is equal to log of and so 10 power minus pH. So if you substitute this one, you get instead of pH, you get the value. So now here next equation related to pH. This is the next equation related to pH. So now here H plus ion concentration H2 we are finding. So if you want to calculate the hydrogen electrode means reversely we can write and here minus will come. So that means see look at here how can you write that. So first we take a screenshot I have for notes. See here. So this is the next equation related to pH. So now here, if you want to calculate for the hydrogen concentration, hydrogen electrode concentration. So hydrogen electrode concentration. Hydrogen electrode concentration So E of H2 by H plus. Look at here. For hydrogen gas vector, that is for H plus ion. So E of H2 by H. Simply I am reversing this one. H2 becomes here, H plus becomes there. So the E of H is equal to minus will come here 0.059. So if it is reverse, what happened here? Minus will come. That's all. So log of H plus ion concentration to base 10. Log of H plus ion concentration to base. So these are very important to do the problem. This is very important to do the problems. So now we will go and do one problem regarding this. So this equation is hydrogen electrode concentration equation. Now one problem is given like this. Look at here. Calculate the potential of hydrogen electrode placed in a solution of pH 10. Calculate the potential of hydrogen electrode, potential of hydrogen electrode, potential of hydrogen electrode, calculate the potential of hydrogen electrode placed in a solution of pH 10. pH 10. pH is 10. Is given as pH is given as 10. Now see look at here. So answer. So here the problem is given as calculate the potential of hydrogen electrode. So now we are going to calculate the potential of hydrogen electrode placed in a solution of pH is 10. pH is 10 is given. So how can you do this one? Look at here. So we know the formula potential of hydrogen electrode potential EH2 by H plus. Last equation what we wrote here, that one EH2 by H plus is equal to minus 0.059 log of H plus concentration base 10. H plus concentration base 10. H plus concentration base 10. So now look at here. So what is given here? pH is given. So we have to calculate the potential. That means this one we have to calculate. So E of H2 by H plus is equal to minus 0.059 log of pH is given. Look at here. pH is given as 10. pH is given as 10. So this pH is given as 10. pH is equal to 10. H plus ion concentration is equal to 10 power minus pH. So H plus concentration is equal to 10 power minus 10. So now here, so H plus ion concentration how much is given? 10 power minus 10 base 10. 10 power minus 10 base 10. So as per previous formula, 10 power a power x becomes here. So E of H plus ion H2 by H plus ion concentration is equal to minus 0.059. This becomes here minus 10 into log 10 base 10 log x base x, that is equal to 1. This becomes 1. This total becomes 1. Becomes 1. So now here if you write here, look at here. E of H2 by H plus E of H2 by H plus is equal to, see look at here, minus 10 into this one, so that means 0.59. It becomes as 0.59. Minus into minus plus, and 10 into 0.05 means 0.59. Log 10 base 10, that is equal to 1. That is equal to 1. Log 10 base 10. This log 10 base 10 becomes 1. So now here, the electrode potential of hydrogen electrode. The electrode C, the potential of hydrogen electrode is equal to 0.59. The same question asked in 2017 NEET. The electrode potential of the electrode potential of hydrogen electrode placed in the solution of pH is 10. So what is the answer? Calculate the electrode potential here. The options is given. Option A 0.059. Option B 0.0226. Option C 0.59. Option D 0.01. So what is the answer here? What is the answer for this? 0.5. So in this way you can calculate the problem. So simple. We have to calculate the potential of hydrogen electrode. Hydrogen electrode means EH2 by H plus. Minus 0.059 log of H plus by H plus concentration base 10. This is the formula. By using this formula we can calculate all this. So pH is equal to 10. H plus ion concentration 10 power minus pH. By doing this we can calculate the problem. So one more problem we do. So we do one more problem. So standard EMF at alien cell is 1.1. So it is given as standard EMF E naught cell is equal to 1.1 volts. E naught cell is equal to 1.1 volts. Calculate the standard Gibbs energy. Standard Gibbs energy. Calculate the standard Gibbs energy. So standard Gibbs energy is delta G naught. We have to calculate. We have the cell. So here of the cell is given. Of the cell, some cell reactor is given. cell reaction, that is Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Zn plus 2 plus Cu. So in this way, what you have to calculate this one? Look at here. So E0 cell is given, standard EMF cell is given 1.1 volts. Calculate the standard Gibbs energy of the cell. This cell is given like this. So now here we know standard Gibbs energy delta G0 is equal to minus NF E0 cell, minus NF E0 cell. So now here this is the formula. So in this we are just substituting this number of electrons transferred for a linear cell 2 into Faraday's Coulomb charge. So it is 96,500 coulombs into E0 cell. How much E0 cell is given? 1.1 volts. Just to substitute this 1.1 volts. Now here the delta G0 is equal to 2 into 1.1, that is 2.2 into 96,500. 96,500. So here delta G0 is equal to minus 2.2 into 96.5 K joules. You can write as joules. In this way, multiply this, you get the answer. In this way, you can calculate the problem. So this is today we discuss about Nernst equation, and Nernst equation relates with other terms, that is Gibbs energy, equilibrium constant, and also pH, and also how Nernst equation you can write with what the Nernst equation with the pH, and Nernst equation related with the Gibbs energy, Nernst equation related to equilibrium constant, Nernst equation related to reaction coefficient, Nernst equation for general reaction. We all write down, and also we did the problems based on this. And next we are going to the next topic of the electrochemistry.